Okay, great. All right, guys. So the call's being recorded now, so should be capturing everything that we're saying, all the questions that we have.
Okay.
So I guess for starters, what's your guys' experience so far with exposing wafers? Do you guys use masks?
Yeah.
You guys have a mask aligner on site? Okay. And so the motivation for getting this is to be able to, instead of using masks, you guys want to directly write on the wafers? Okay. All right. So Wei Liang, so can we close the software and can we just start from square one?
Right, sure.
And I tried it on my phone this time because it's a little bit louder. So we all hear him now because speakers on that were so quiet.
We have some speakers that we can patch.
No, it's working now. I don't want to. Can you guys hear this okay? Wei Liang, do you want to say something real fast?
Hello, testing. Can you hear me?
And this has been recorded, right?
It is, yeah. Yeah.
Where is it being recorded?
Onto this laptop right here.
Okay.
You can see.
Okay. Hopefully on the laptop the sound should be okay.
No, so I tried it on both. I tried it on my laptop and this one. It's really quiet. I don't know why, but Teams is super quiet on the computer. I should invest in
No, once it's recorded,
Oh yeah,
playback.
the audio.
Yeah,
we'll be fine. Yeah,
We'll be fine.
the microphones are picking up fine. It's speakers on the computers are really quiet.
You would have the speaker, I think, just sitting on like a normal portable speaker if you want to try it.
We could try this and because it seems to be picking up our voice pretty well. So we'll move forward with this. All right, Wei Liang. So do you want to walk through like where the software is located?
Right, yeah. So this is the new software that we have updated. So the software version number, it's 2024 September and the second week of September. So this is the new one, and this was the one that came with the laptop. So it's in April. Right, yeah. So I made a shortcut. So when you launch the shortcut, it should launch the software. So I'll just remove everything, unpin this, and yeah, just double click and it will launch. Okay, did I do a double click? All right, yeah.
Yeah, it might be some issues just with the delay from Singapore, but
yeah.
Okay, so that's all.
That's about like an external HDMI recorder. That'd probably be the way to go. Then I can record the screen without messing with the quality.
Okay. So I think let's do that again because it's not scaling to the Windows nicely.
Yeah, the team screen sharing might be messing that up a bit, but no, there we go. Okay.
Yeah. All right, yeah. So you just need to turn on the software, and the first thing you will realize is that if the equipment is turned on, you will see this green lamp lit up, and the camera is live. The LED is on. So anything that's green, it's good. So do check for this tree.
Wait, then can you show them what it looks like disconnected?
Oh yeah, sure.
You guys see that's red? It means it's not achieving a signal. There's either a problem with the cable, or you need to come and click that button to connect.
Yeah. So I'll just turn that on right now again. Yeah. So now it's all good.
So this is ideal where you already have the perfect focus and you don't need to go find your chip. But Wei Liang, do you mind moving the stage? Can we move the stage forward and then we can try to find the chip?
Do you have a chip on there already?
We do, yeah. So that's what we're looking at is a chip coated with
sure,
photoresist. Yeah, so let me pull the stage out. So this is also how you guys would load samples. So WASD will move the stage around and the camera. WASD, just like a video game. So just like walking in a video game, you'll move forward and back. And then if you want to go faster, you can hold shift. And then holding shift while moving will make it move much faster.
We'll definitely forget the...
And yeah, we have a list of shortcuts, no problem.
But do you have anything here graphically that I can use to move it?
No, in this case, this is one of the controls that would need to be remembered is the WASD.
WASD.
Yeah.
WAS.
Or even the arrow keys will work. The arrow keys on the right side of the keyboard.
What if W is it? Because just W is moving it down.
Oh yeah. So you could also use the arrow keys.
Okay, that's
So
much more better.
This laptop happens to have really nice arrow keys. Most of them have them shoved up in the corner, so I don't usually use those.
Okay.
Cool. All right. So yes, for an example, we'd go forward. We'd
Mhm.
load a sample. So you would take like tweezers or your chip and put it into position.
Mm-hmm.
Just roughly wherever. We'll zero it out later, so it doesn't need to be in the dead center or anything like that.
Sure.
And then we'll essentially start moving with the arrow keys back to the chip. And here's an important thing: if the last person who used it was using like a really thin chip or a really thin wafer, let's just call it like a 0.4 micron or something like, or 0.4 micron thick, and they had and you had focused down to that level, and the next person puts a 1.2 millimeter chip in there, you're gonna run the optics right into there if you're just moving. So one thing you always want to do is visually look in here. This
Yeah.
laser can't hurt your eyes.
Right.
First of all, the focus is so tiny that it would be impossible for your eyes, but it's also being run at like 2% of its total power. So it's a very low power laser. So there's no concern looking into this dot, even when the tool's running, and right now it's not running. So don't be afraid to get in there and actually look. It won't hurt you.
How
And-
to get it down, up
yeah.
and down?
Yeah, so that's easy to remember. It's just page up and page down, and the way that you remember that is stage up and stage down.
Page up and
So
stage down.
so if you physically look and you think that you're too
Very
close
page
to
up here.
yeah, so if you think that you're too close to the sample, yeah, you'll just literally move the stage down by going page down, move the stage up by going stage up.
I see.
So in this case, we've lost focus. So even though we're on the chip, you guys can see
Nothing. Yeah.
this is us off the chip. This is us on your chip.
Mhm.
You can see that something's happening, but you can't see because we're not focused. There is an autofocus built into the tool, but it only works within a certain range. So, and you can adjust that range to be as wide as you want, but then it has to do a full sweep. And we generally want to keep the autofocus range small, since it's much faster that way. So manually, what we do is you can physically look in there. And Wei Ling, what's the actual focal distance?
From the lens to the substrate is 1 millimeter.
Okay, so then we just need to essentially start moving down slowly
Mhm.
until we're 1 millimeter away.
Down or up?
Oh, sorry, up.
For the-
Yeah.
Okay.
And then eventually you'll see it start to come into focus.
Yep.
And a good way to double check that you're not just focusing on the internal like optics or anything is to start moving around. Once you're close, a nice thing to do is to go to the edge of your wafer or the edge of your chip. That gives you really high contrast. And then you can then autofocus, and that'll find immediate focus right there.
Mhm.
You can also autofocus, but if your chips are much better than this,
Yeah.
and there's nothing to focus on, it's going to have a hard time achieving that focus. So I would always recommend moving to the edge, filling up most of the view window with your sample, and then go ahead and focus, and it'll find the focus.
Mhm.
And then you can move back to where you want. So Wei Ling, so now that we found the chip, let's just say what's the next step that they would do?
Right. So we just talk a little bit more about the controls, right? There are a few speed modifiers, shift and space, that will make the system move faster or slower. So you have like modifiers, and then for fine focusing, you also have the mouse wheel. You can use the mouse, just wheel up or wheel down, and then you can do
Yeah.
fine
So
control.
if you guys have any desktop mouse sitting
Sure.
around, you can use the scroll wheel on that to manually focus.
Mhm.
You can also try to use 2 fingers, but that's not as easy.
Yeah.
It's nice to have like a scroll with a click
Mhm.
on it. That way you can manually focus.
Yeah. Then the other thing is that you can right click anywhere on the camera window. Like I want to look at this dirt. I just do a right click and it should zoom in there. So it's helpful for moving short distances precisely. So right click to move.
Yeah, so there's a
And then,
relationship between the camera viewpoint on the right and where the drawing's being sketched on the left. Right clicking on either should bring you to that exact position. So when you guys have a whole like drawing loaded,
Mhm.
you guys can right click on that drawing and it'll bring you onto the wafer where it's going to write that.
Come again? I
Yeah.
So you
It'll
have to
be
wait for-
easier to show you once
Yeah.
we have
Yeah.
something loaded. Yeah.
Right, okay, so that's for the controls, and for the positions is actually displayed here under the stepper. So as you are moving, you can see that the X and Y coordinates are changing. So this coordinates is important because we always start exposing at 0, 0, where the bottom left of your designs are. So if I do a 0 now, and if I load any files, it will start exposing right here. The bottom left will start here, where this black square is. Yeah. And of course, you if you want to move like 1,000 microns, you can just type in here as well. Same for the X, Y, and Z. So if you notice
that's the reference point.
Yeah. This is the new reference point right now. And if you realize for the Z, we do have like a absolute value here. It's negative 400 microns. So it means that the stage is down by minus 400 microns, and that makes sense because the wafer I think is about 450 microns, I think. So you have to move the stage down so that when you put the substrate on top, the height adds up to 0. So stage plus sample equals to 0. So sample is 400 microns. And yeah. So if you do have like a new piece of wafer, you can use a vernier caliper to measure the.
Yeah, it is. Yeah.
So for X and Y, there's no absolute positioning, not really, but for the Z there is. Yeah. So that's like a very quick way for you to do autofocus. Yeah. Okay. So that's all for the movements, right? For the camera, you can change the brightness of the camera, the exposure of the camera by dragging this slider. So I think most of the time this is fine. Whatever default value is fine. But you may run into situations where it's overexposed. Yeah. For certain samples, right, you have a very dark substrate and a very bright metal electrode. So you might want to adjust this a little bit. Yeah, just using this slider. Okay, and in the camera window, what's important is capture. So it will capture an image, and when you click folder, it goes there. Yeah. Okay. There's a ruler function, right? Yeah. But I mean, this is only good for larger dimensions. But if you are working with like submicron, it's a little bit small to select like this. So you do have to use the capture button instead. Yeah. Okay, so that's for the camera controls. This is what is important. So I think we can go to patterning right now. So for patterning, there are 3 modes, right? So the first one I will demonstrate is the GDS. So okay, let me just load in a GDS, right? All cross. Yep. So just select the GDS you want to expose, and I mean, because the GDS is made up with cells, it doesn't know which is the top hierarchy cells. We have to tell it. So in this case, I know it's the top cell. Okay, so when we open our GDS, this is a Hall cross structure. So layer 1, you are patterning the crosses. Layer 2, you are patterning the electrodes. And layer 3 and 4 are for more. We'll do some demonstrations with that, right, later. So let's say we want to expose the cross. Make sure that exposure layer is layer 1. Yeah.
So which software did you use to develop that?
Yeah. So we have Wei Ling, what's the software down there? MATLAB, or what's the one that we use?
K-Layout.
K-Layout. That's it. Yeah.
K-Layout.
K-Layout, which I believe is open source.
Oh, that is?
Yeah.
Okay.
Yeah.
Yes, this is how you could lay out your circuits.
Okay.
Use them later, and that can be done at home on their laptops as well.
It's a K-Layout.
K-Layout. Yeah.
Yeah.
I think
So
there's even a
that's
version. Well.
yeah. All right. This is software. Oh wait, where was I? Right, I was here. Okay, so right, once the preview loaded, you can choose which exposure layer you want to expose. So this is layer 1. Click OK. Yeah. So it loads the crosses. I think these are 5 micron crosses. So as I mentioned before, if we go to a location and we click 0, 0, you can see what's happening is that this box here represents where we are looking at right now, and if I click it, this
So every
box,
time you guys push 0 right here, so right here on the pattern, it comes here. So that's how you can move your chip around to wherever you guys want. By moving this screen around to where you want to go, the relationship is right there, comes right there.
Okay.
The bottom left corner.
So once you have loaded your pattern, right, you could also like just zoom around.
This is what I was telling you before. So there's a relationship between the two. So if you wanted to zoom in on a certain part of your pattern, which is more important later when you're doing multi-point layer alignment, you're able to just right click. So that would be on here, it'd be 2 clicks. And if you guys have an extra mouse to put on there, even better. And that would be a right click on the mouse would then move you to the next location.
Right. So this is helpful, right? If you want to make sure that all your patterns are on the silicon wafer. So we just found that we are right on the edge of the wafer. So I'll just move in a little, click 0. And now when I check the extent of it, yeah, it's just barely within the wafer right now. Yeah. So with that, we can just click expose, right? So once you have loaded the file, chosen the layer to expose, and make sure that it's in a good place, you can just click expose. So under the camera, we have another option to increase the contrast. So that is control left click on live, and then it turns orange, and the image will, yeah, the contrast will be much greater. Right, so now we can see that everything is exposed. We can even do this test where we go to the middle of one of the hot crosses, and yeah, it should go there. Yeah.
So how do you set the exposure time and settings over there? Okay.
Yeah. So these are the settings that are safe to adjust without breaking the system. And then for this, it needs to be unlocked to ensure that it's not changed at random. Yeah.
So if let's say if I'm working with a new photoresist with a different thickness of the photoresist, how do I, and then from the spec sheet, I know what the exposure conditions should be. How do I translate that to here?
Right. That's a great question, right? So even though there's like something that's given in the spec sheet, right, we always recommend that you have to find the exposure power on the system like experimentally. So we do have some calibration tools, which I can jump over to quickly. So this is so the password, the pin to unlock any of the calibrations is 0805. So with that, you can unlock the calibrations and.
Is that in the manual?
Nope.
Nope.
I
would write that. Yeah, I'd write that one down.
Yeah, I mean, if it's in the manual, it's too accessible, right?
Okay.
Right. Okay. So.
Well, Wei-Liang, now it's on the training video.
All right.
Just kidding. All right.
Yeah. So how we would recognize if the exposure is, we need to increase the dose or decrease the dose is using this. So this is like an array of 9 × 9 squares. So moving from left to right, we are increasing the exposure power. and bottom to top, you are increasing the exposed offset. So this is like so how I would
So it's like a sweep that you can then look at
Yeah.
with your guys' microscope and figure out which one was perfect. And then we could go back and select the right mix for you guys.
So for
Yeah.
that, I need to come to the calibration values.
Yeah.
Is it?
Yeah, Wei Ling, do you want to show where that is one more time?
Yeah, it's to open this window, you just have to come here in the main window calibrations. It's really tiny. Yeah.
Uh-huh.
Yeah. So once you're in, you can look at these figures and right. So how I would judge is when the color stops turning more yellowish, you know that the exposure is saturated. The photoresist is fully saturated.
No, I think I'm done. What is this figure? Is this the picture of a exposed photoresist? Oh, this
yeah.
one?
Yeah.
Of that?
It's the software analyzing the exposure. So it does the exposure, it takes a picture, and then the software analyzes the exposure and gives you a graph here that's trying to show you where the optimal exposure is for your photoresist.
But what about like a very thick photoresist, like SU8?
SU8, yeah.
SU8, which is transparent and
Well, SU8,
they
I
may
think
not
it's
have.
a bit. Yeah, I
You'd
think
have
it's
to
a bit
expose
harder
it
to
first,
use.
right? Yeah, Wei Ling, would they have to expose it and then bring it back to do the analysis?
Yep. So for that, we have a job queue function, which I can spend a bit more time to discuss later. Okay, or even now, right? You can just do this. What it means is that it will do 4 exposures at different X and Y coordinates, exposure, focus offsets, and things like that. So you can basically automate an experiment. So for example, if you are testing the exposure power, do this, right? So at each coordinate, you'll be exposing at a different exposure power. And so you can test all the exposure powers, develop it, and then go and
percentage of
look
exposure.
it.
Right? So when you say exposure power, we are talking about the percentage of the laser power.
Yeah, the laser's only been run at about 2 to 5% of its total power. So we have a full range that you can increase the exposure power.
Okay, so when you say 500 exposure, what does that mean? Exposure of 500. Does that mean
0.1 microwatt per unit? So it's 50 microwatt right now.
Oh, so when you hover over it, it shows you the unit.
where is it?
So you see, if you hover over it,
Oh,
it
okay.
shows you the unit.
I see.
Yeah.
So 500.
Yeah. So it works a little bit different as compared to a mask lithography, right? That gives you the exposure power per area. But because we are focusing everything down into a laser spot, it's hard to give a aerial density. So
okay.
we control the laser power instead.
Okay.
Yeah. So anyways, job queue, you have the flexibility to change. So you can basically repeat the experiments with slightly different parameters. And then once you're done, you can click start. Yeah.
But we have had many customers use this with SU8.
SU8?
Yeah.
Okay.
Yeah. So okay, let's come back to our original pattern here. Yeah, it's really hard to see. Okay. The next thing that we might want to do is to do alignment. So as you can tell, my camera and the GDS file is not synchronized right now because I'm apparently looking at one of the crossbars and it thinks that I'm somewhere else. So it's the perfect time to talk about alignment. So let's say I'm done with the first layer. Now I open up the same GDS file. And I want to pattern the electrodes now.
Okay, so this is an
So-
example of when you take the chip off, go process it somewhere, and then you bring it back to do the second layer. This is how you would then realign it. So some of the more expensive, larger systems have these advanced stages that rotate and move it in different axes to try to make this work. The way that we do it is in software. So once you achieve the autofocus in software, everything just snaps into position and then it exposes like that.
The question I was about to ask, like the alignment
Yeah.
mark.
So the number one thing that breaks, the number one thing that breaks on all of the larger tools like the Heidelbergs and the Race is the
with
stage.
respect to the software, right?
It does it in
that
software,
alignment-
yeah. There's two things. One, a lot of them use
Alignment
expensive vacuum stages, and the vacuum stages are usually perfectly flat. And then what happens if you have a particle or a piece of dust or anything, you then get a situation where your sample isn't flat. So what we've done, instead of using a vacuum stage, we've powder coated with a relatively thick powder coat material throughout the entire stage. That way, when you lay your sample down, any particles that are smaller than the powder coating material won't interfere with how flat your sample is. So and it also provides a nice grip on the back of the sample so that it's not sliding around. If you look at some of like the larger like rate tools, they move very quickly. And so this tool does move slower, but that's a benefit for us because we're not using vacuum to hold the sample down. So
Run on complete silicon wafer.
Yeah.
Complete silicon wafer.
yeah. So you could fit, I think, up to
So the silicon
5
wafer, let's say if we put some alignment mark, usually people put on the one corners, right?
Yeah.
Mainly on the corners. And then when we do the second layer, then how the system will detect? Will it like
here's where he's going into it right now. So
So it looks like we
We-
don't
we-
need alignment marks here, right?
so we do. So we just put down the alignment marks. You can use any feature you want to, but
suppose
alignment marks is
if
the best.
we have more than 2 to 3 lithography steps,
Mhm.
then alignment mark is necessary, right? Because like, suppose like, you do patterning over here and in the next photolithography step, you do in between. So
Yep.
alignment mark is very
So then
necessary.
you would have to have an external alignment mark. Yeah.
Yeah.
And that's so he's about to show you 3-point alignment by doing that.
And how the wafer it will set accordingly. It's like, once we do like, suppose like, we do these 2 lines,
Yeah.
the third one we have to do in between.
Yep.
Right?
Let's see.
So you've added another layer on and now we're exposing over a different part. Yeah. So you'll have to make sure that your exposure mark is visible.
Yeah.
So that would be designing an exposure mark outside of the chip area that you're working and making sure that when you achieve the next layer, you're also removing the next layer so that you can see that original
I was asked
cross.
the placement of the silicon wafer. They will always replace randomly anywhere or
Yeah, randomly anywhere. Yeah,
anywhere.
Yeah,
Then it will adjust accordingly with respect to the alignment mark.
that's correct. Yeah. And he'll show you right now. So Wei Liang, do you want to show us the alignment?
Oh, yeah, sure. So the layer that we want to expose now is the second layer. So we choose layer 2, click OK.
Mhm.
So yeah, now it's loading the electrodes. Okay, so the button that we want to press right now is align. So when this pops up, it asks which layer do you want to align to? So layer 1, 4-point alignment, and all these other settings we would leave it default. Okay, click OK. So the mask goes back to layer 1. So how are we going to align this with what we have exposed? Usually the contrast will be a lot better because after you develop, the edges will show up much better. So for now, it's a bit harder. So the first way I'm going to do is by clicking. Okay, so to bring the mask onto the camera, do a Control left click. So if you can see, it's a little, this cross is highlighted here, and this is what is being shown on the screen here. So just click and drag it around, and then yeah, I can't see that clearly, but okay, I'm just gonna go with it. And then if you go to the other cross here, oh, I might have missed one. Okay, so there's an offset, but I don't think that matters, right? Because this is periodic. So same thing here. I'm going to just Control click and then it brings out the blue color overlay. I'm going to try to use the automatic. Nah, it doesn't work. Okay, so we do
usually
have
if you
a
have a sample in high contrast, it just snaps the vision
Let's
board.
if it is at because we will place the wafer randomly, and instead of this plus this side, suppose this is at some angle, will it rotate?
Yes, it will. Yeah.
How it will do that? It will like
So wait, so Wei-Liang, do you want to show rotation now, or should we save that for after?
well, the rotation happens automatically, and usually it just rotates the mask in the software, right?
Yeah. Yeah.
So anyways,
We'll
I think
show
you
you in a
can,
second. Yeah.
we
Understood. Yeah.
like we place like this, we place like that because they will put place
And
randomly.
it accounts for that. Yeah. So we'll show you in a sec.
right, yeah. So
then it's very cool system.
It is, yeah. So I mean, there's advantages and disadvantages. So for one, on the other tools, you have a much more advanced stage, much more expensive, much more likely to fail. And then with ours, you get issues of rasterization if you're trying to write features that are smaller than 0.6 micron or sorry 6 mic. Now you
What the
can't.
smallest this can write?
Yeah, so it's using a 405 nanometer laser, and we rate it for about 800.
800 and
Yeah. The line is more similar to 5 to 7, but we do rate it for 8.
right, okay. So the alignment is done. You can see here that there's a little bit of rotation, 0.0125 degrees, and a tiny translation. So, anyways, we'll just go ahead with the exposure.
nice.
So of course, I think we misaligned the first hot cross, right? We missed the first one.
Yeah. Yep.
That's pretty cool. Yeah.
Suppose you can also see it exposing in like real time. I always like when it stitches the next one together and you can temporarily see a difference in color. Just interesting. It's a cool photoresist. Not a lot of them do this where you, where you can watch it write in real time. Yeah, most of the time when you write like on SU8, you don't even see it.
Yeah, that's
It's
the problem.
until you expose it.
You won't be able to
Yeah,
see it.
yeah.
Yeah, they miss.
All players there on that one step? Or does it feel?
Yeah, you can. Wei-Liang, his question is, can we expose multiple layers at the same time if we wanted to?
The way to do it, I would suggest, is to combine it in K-layout. So like if you want to expose layer 1 and layer 2 together, you have to select that and move them to the same layer.
Different.
Okay.
Okay, so yeah, make a new layer with everything combined. Yeah.
Yeah, you can see red one has, let's say, silicon dioxide, and green one will have some not.
Yep. So I think that's the first method of exposing using the GDS. And the second way I think is more fun. You can draw on the screen.
So part of the function is that you can draw custom shapes.
So let's say I'm trying to work with graphene. Let's say I have the graphene on the wafer. And then I coated that with photoresist. And then I'd like to put electrodes on the graphene, just like I should be able to do that with a custom.
Yes.
Yeah, definitely.
Yeah. Sorry.
I think that's where this system is really convenient for. Okay, so I've used all the different kind of primitives, right? Polygon, circle, rectangle, and text. So like for any of the primitives, you can double click and change the length. So You can change the length of the rectangle for the text. You can change the font size. Circle, you can change the radius. And then you could also, by double clicking on everything, you can make it rotate clockwise or anti-clockwise, or to shift it a bit left. And let's see if this works. Copy. Yeah, it works now. This actually, most of the features here are customer requests. Yeah. So yeah. Okay, and when we are done, we can just click OK and just expose.
So this is like a way of skipping having to go create the pattern in another program. You just want to change geometry really fast.
Yeah.
Or in this case, like adding a serial number to your wafer chip or something like that.
Yeah, so that's the second way of second exposure method. And of course, I think the last method is to use a image, right? So I saw Zachary pattern some nice cool images. You know where they are at?
They're in
They are not here?
downloads. Downloads. Yeah.
So which one is nice? PNG pattern. This one?
The round one's kind of cool. The top one, the round.
One, right. Okay, so usually we will try to pattern the university logo. Oh wow, this is.
Yeah, this one takes a while to write.
This
takes a while to write in
challenging.
vector mode.
Yeah.
Oh, that one's less than 400 micron. I think it's like 200 micron across.
Oh,
I've
okay.
got my microns and millimeters mixed up today. I can't. I need to have more caffeine. I think I said 0.3
Okay.
micron earlier.
So
That's small.
that's a good point. Maybe I will make it like one right field, then close to 400 microns. Yeah. Okay, so as usual, I will click 0, and that will bring me to the bottom left of the image that I would like to expose. Okay, then click. Yeah, I think it's going to take some time.
Wire fields, right fields.
Yeah, so it's slicing it right now to slices. And one of the customers requested, I guess they had critical geometry between two different right fields. And this was back when we had the alignment is much better now. We had a little bit worse alignment in the past. And so what they wanted was the ability to define where the right field was. So they wanted to be able to pick having the right field move over on the second layer. And so that's been added. So if you have critical, so we just saw an example of the crosses, right? And those were critical. And so if you were to space those out, for example, so that they were in the center of every right field, when you did the next layer, if you had critical geometry that was now between two right fields, you can modify that now and move the right field over. That way you're not dealing with critical geometry being stitched. Because even though if it's like wide, if you're dealing with like a 1 millimeter wide or like a 0.5 millimeter wide pad going across, it's fine. It doesn't matter. But if you're dealing with something that's extremely fine like this and you're trying to stitch two right fields together, you could have misalignment. Yeah, Wei Lian, can you show us alignment, changing the right field on the second layer?
All right. So I'll just go back to the previous example using the Horcross. Yeah. Top. Okay. So back to this example here. Actually, what layer 4 is that we can pretend that layer 4 is where the critical geometry is. I know it should be like inside the nanowire area, but I just wanted to try something funny. So the purple box here, you can define it as the right field layer. So when you're exposing the electrodes now, okay, you see what it will do is that it will make sure that whatever you have drawn in purple, right, it will expose in one right field. So Yeah.
So as long as the area is less than 400 by 400 micron, well, it no longer tries to stitch half a field together.
Yeah. So let me delete this layer and like usually what I will do is this. I think this makes more sense. Yeah. So this is where the micro wire is, and we don't want to chop it up into two right fields, right? Safe. Oh, yep. So now if we were to choose the right field layer to be layer 4, we will ensure that each of these crosses will
The
be one right
exposure
field of the
layer
whole.
and then white field layer. I'm kind of confused with that one.
Yeah, sorry. So what was
The exposure layer, we have, that's the layer that we want to expose.
Yep.
And the white field layer, what is that?
So in that case, we're aligning. So the pop-up field that he had, I believe, was pointing to the layer that you're aligning to. Wayland, can you show that pop-up that you just had again?
Oh yeah, sure.
We were trying to read the text on there.
Yeah.
Yeah.
Yeah,
Define what these two mean. So exposure layer and right field layer.
yeah,
That's a good
exposure
question.
layer, I think this is clear, right? What we want to expose. And right field layer is we want to use this layer not for exposure, but to tell us where to determine the right field, where we want the right fields to be.
Okay, so he's saying you can have your own layer that is defining where you want your right fields to be. So in this case, so Wayland, one more time, can you show? So he created this pattern on layer 4,
right?
And so now it's going to target those right fields. So you can essentially use this if you have a thin wire. Let's say a thin wire that's going 2 millimeters across the span. You can define what right fields you want to have across that by using this layer.
Can you define what right field is? I'm still trying to wrap my mind.
Yeah. So
What's the right field?
where you achieve the highest uniformity and precision is when nothing is moving. So when no motors are moving, and the only thing that's moving is the laser back and forth across the right
So that's
field.
the right field.
Yeah, the right field. It's the 400 by 400 micron area that we're looking at.
Right.
So every time we move, there's an accuracy. There's an accuracy in the motor. There's repeatability issues.
Right.
It's been massively improved with this one. We're very good now. But in the past, like on V1 of this tool, if you had a thin line that was maybe let's call it like 10 micron moving across, when you stitch the two together, you notice a physical difference.
So basically you have two right fields, you're trying to align them together.
Yeah. So nowadays the alignment's so damn good. It really does stay uniform. But if you're doing really critical geometry, you want to make sure that you're defining where you want to have the stitches, basically. Stitches between fields. You want to pick that. So especially if you're doing really fine work, you want to make sure that in this case, he's given an example of he created layer 4 here, which is this red area.
Right.
And he's saying this is a critical area that I want you to write without stitches.
Okay.
So go to all these areas here and write without stitching, because I want to make sure that we don't make a mistake.
Okay.
Yep. So just to say it again, exposure layer 1, right field layer 4, and this is what you get. Each of the right field will be this red, highlighted in red, right? So you notice that you have 5 times 5, I think. 5 times 5, so you have 25 right fields. So in the other case where I will tell the system that, hey, I'm not telling you what to do, decide on your own. And right now it's possible that they will group together a few crosses and write it together to save time. So I hope
So the software tries to avoid having stitches.
So you said 40 microns is the width of the right field?
It's 400 micron.
400 microns.
Yeah, so 400 by 400.
400 by
Yeah.
400.
And when you save it, when you capture an image like what we showed earlier,
Mhm.
that's the file that's saved.
Mm.
It's 400 pixels by
Every
400
time we
pixels.
can use this file as a alignment mark on samples, right?
Yeah, so you can so
Place it on one corner.
yeah, so you don't have to so we have an abundance of alignment marks here that they're not really alignment marks, these are micro traces, but you could have these same alignment marks off of your pattern and you can do whatever you want. You could have a square, triangle. It's really nice when you do a cross like this
Yeah, yeah,
because when you have 4 of them spread out across a large area,
yeah.
it does a great job with rotation. So like
Yeah.
if you're, as you said, when you take a chip out, put it back in, you're never going to get the exact same alignment as what you had before.
Yeah.
You're going to be, I mean, try to fix it as best you can and get as close as you can with tweezers. Like rotate the chip to make sure it looks as good as you can. But then you're going to be using scroll wheel. So when you're doing the alignment, if you have a mouse, you can use the scroll wheel. If not, you're going swiping up and swiping down. And I think Wei Ling, it's Q and E, right, to rotate.
Yep. The photo mask. Yep.
You mind showing that? Like, can I rotate the chip a little bit and then you can show us?
I work with other machines where manually we do. So what we do, suppose we have silicon wafer, we put alignment marks on all corners, like this corner, this corner, this corner, this corner. So that like sometimes it matches with here. So we just try to match with here and that's that. We just want to make sure that it exactly do. Otherwise, you know,
Yeah.
will all mess.
So the goal with this is to do the best that you can, and then you can push the auto align button. And in this case, you can see there's a lot of issues here. We got a lot of particles, a lot of previous patterns up the it. It's not a perfect smooth film, but when you have a high exposure area, I would say more than 75% of the time, you just push the auto align button and it'll snap to the alignment marks. So Wei Ling, do you mind if I rotate the chip down?
Yeah.
Yeah, I'm
Please
just gonna
go ahead.
rotate.
Yep.
I'll rotate just a little bit. And so if you can show us now how we would rotate the layer to align.
So maybe I can use this for alignment. I think this is the third cross. So we can do a, wow, okay, I was pretty close already. So you can press Q and E to do rotation.
So these move
Yeah.
around, then Q and E are how we rotate to the left and to the right.
Q and E.
Yeah, Q and E right above.
So maybe you
Yeah.
should get us a PDF file with all the shortcuts we can print and
Yeah, Wei Ling, have we worked on that yet? The shortcut list?
Oh yeah,
If
I
not,
think
that's
it
something.
should be. It should be in the manual. If not, yeah, I have that as well.
Rotate to match.
When you rotate, it was showing like this, but over here it should show straight.
no, he rotated it.
No, so he's rotated it. Yeah.
Now it will automatically follow you. Once we lock it, maybe it will.
Yeah, let's see what happens when he finishes.
Yeah, so it rotates the GDS again. Because if you're doing a manual rotation, you can never be as accurate as the software. So I've used these points for alignment, right? 1, 2, 3, 4, and let's go to somewhere in the middle for confirmation. So right. So we have used 4 corners, and now we are checking somewhere in the middle, and it's spot on. And we can see that the rotation is another 0.7 degrees.
Can we
from
do
our
this again?
manual.
Can we pick another one? How would we do align? Do you need to like the align thing? Or
Yeah.
how do we get that mark?
How do we get the alignment? Yeah, do you mind doing the align procedure one more time? Like that?
Line?
Yeah, here. Layer for alignment, layer 1, because in GDS the crosses are on layer 1. Click OK. So to bring out the mask, just Control left click here, Control left click, and
Control left.
Yeah.
Okay.
Click OK. So I'm using this one and use any 4 points, but in theory they should all be spaced apart.
Yeah, this is like a worst case scenario for the auto alignment because there's pads there, so it's not going to be happy about that.
Mhm.
You generally want a
Yeah.
high contrast mark that's on its own somewhere else.
Yep. So anyways, yeah, you just do that for 4 times. So 4 times is the minimum you need for translation, rotation, stretch, and skew. So yeah, with that, I think you can see that the rotation this time is much lesser, it's 0.04 degrees.
Mhm.
Yep. So the first time when we rotated the sample and we did the alignment, the rotation error is much bigger. 0.7 degrees. Now it's like more than 10 times less. Yeah. And if we do a random check, this is where we have not aligned before, and then we just hit over there, it should be spot on. Yeah.
Yeah, so if you guys can see, it's hard to see back there, but there is a little black square,
Mhm.
and that shows you where we're looking at, so where you've clicked. So he went into the pattern and clicked exactly in the middle, and it immediately snapped to the right position. And you can do that on any geometry to check on your pattern. Just move anywhere to check and see.
Right.
Cool.
Yeah, I think
That's
that's
the
for
This
alignment,
is
right?
this
Yeah.
is our approach, this is our way of doing it. It's far more robust. You're not going to have issues with state
I was
failing.
thinking that this is the software part and this is the actual where laser is viewing, right?
So
Is it true?
yeah, this is true. So on the left-hand side, you have
So when you rotate the wafer, this also rotated.
so the wafer has never moved. The camera has never moved.
Okay.
The only thing that has moved is we've shifted the pattern to the right. So you can even see our camera is still rotated. So
You did from there.
all I did was I moved the chip. So I rotated the chip 3 or 2
Chip
degrees.
is like the silicon chip, right?
Yeah, yeah. I physically rotated the silicon chip
Yeah,
as if
that's
it's
what I'm saying. When you rotate the chip,
yeah.
how this software file also rotated.
Yeah, so what the procedure that we just did by picking 4 points, it's able to get rotation, stretch, skew. It does basically a calculation to try to figure out where we're supposed to. And then from then on it skews your entire GDS file to match that.
The software does it that much fast, right?
It does it automatically. So it's doing all those calculations to the GDS file on the fly.
Very good.
Now, in a perfect world, do you want to put the sample exactly back the way it was in the perfect orientation? Sure, but nobody can do that.
Yep.
You'd have to have some kind of advanced stage with pins or something on there to do that.
Yeah, it's not very practical.
Yeah.
Yeah. Okay, that's really good.
Well, what other? So
once
you guys have a sample of the photoresist ready to go? It's okay if you don't, but it'd be fun to
No.
it'd be fun to try it out.
we could code this. Pick one. This the thing going working. You can do an SA1830.
Yeah.
But what photoresist should we use? What are the optimal photoresist to be used for this system?
So
Yeah,
that
so
would
the
be
one
the
that-
AZ701, and then you have a different one in the manual, right? Wei-Liang?
That's AZ701. Okay.
Yeah.
Okay, so these are the photoresist. Only we can use any photoresist or
Wei-Liang, do you mind if I take control?
Yeah. Please take control.
I think it takes
So-
all the photoresist or it takes some limited photoresist.
It's what is 420 nanometers?
So AZ701. And
Takes
then you
any
have this,
photoresist, I think.
you have this one
yeah,
in the manual.
AZ52143.
So these are the two that Wei-Liang likes to use. It's either AZ701 or AZ5214E.
Okay, so it is limited only to this photoresist.
No, so any
Any-
photoresist that's sensitive to eye line.
Okay.
So
Yeah.
yeah, and let me load up the manual real
So
fast.
photoresist, they are like function of the laser energy. So any photoresist should work.
So there's a section of the manual that talks about it.
Negative photoresist, negative resistance. NR.
Oh, H line, not I line. Okay.
Go to photoresist.
So any photoresist, and this kind of talks about it a little bit, but any photoresist that's sensitive to 405 nanometer. So SU8, most of them are designed for 375. They're still sensitive to 405. So we're only using this laser at, like I said, like 5% of its total power. And so if you're having an issue with like it not being sensitive enough to the SU8, you can always increase laser power. And we can what I would do if you are in that situation where you're trying to fine tune it is either contact me or contact Wei Liang, and we'll get you the contact info for both of us. And that way you guys can ask us and we can kind of work through it together. And Wei Liang can remote in and help you guys out with stuff like this. So at least for the first year, you guys basically have unlimited access to this kind of troubleshooting. So, and the more questions you ask us, the more we learn about the system too. So it's a kind of a win-win. But yeah, so we do get a lot of customers who buy the same resist that we're using because we have such good success with it. We have just as many customers going out there and trying and experimenting with many different photo resists. So yeah, the important thing is that I believe I think it's H-line.
Yep.
Yeah,
Yep.
H-line and 405 nanometer would be optimal. There's not a lot of 405 nanometer resist compared to 375.
If we go to the Microcam website, I think most of the positive resist will work. Where is this? Photochemicals, photoresist. Wait, is there like a catalog? Yeah, I think almost everything, like I think all these resists, they work. Yeah.
And Wei Liang, what's the thickness limit for you? Is it like 1.3 millimeter, or what's the maximum thickness of film do you really want to be exposing?
Well, the limitation is imposed not by the machine, but what kind of resolution you need. Because the thicker resist you have, the worse resolution you get.
Yeah, because we're focusing the beam basically. So you have a situation where when you have a really thick beam or a really thick film, you have to kind of pick where you want to have your focus. So, for example, a thick layer of SU8, where do you expose? Do you expose on top of the film? Do you expose halfway through the film, the bottom of the film? It's kind of up to you because you're dealing with a situation where your laser is formed into a beam, and so you need to pick where that best is. And so when you have a film that's too thick, you have a situation where you're not really getting optimal exposure to the entire thing, and you're not getting straight walls. And that's the goal, is to have straight walls. So.
Right. Yeah.
So yeah, thin films would be preferred. One sensitive to 405 nanometer would be preferred. What's SU8 you guys have now? What's it sensitive to? Is it 375? You guys know, or what? Have you guys looked at the spec sheet? It's okay if you haven't. Yeah, if you just look at the spec sheet, they usually give you a nice chart showing you the different exposures or the optimal exposure levels at different wavelengths. And Wei Liang, just for me, because I'm an idiot, can you go back and explain positive versus negative photoresist? One's designed to be lifted off, right?
I think both can be used for liftoff. So positive is wherever you expose, it develops, it eats away. And negative is where you expose, it stays. So I think that's SU8.
Okay. I'll have to memorize this chart.
Yeah, positive I think is more common to have. And the other one that this AZ5214E, right? It can be used for positive or negative. So this is quite a nice photoresist, which is why we recommend it. And I think it's sort of like a industry standard as well.
Okay. Yeah. Was he running off to go expose or to go spin?
I think he was looking for photo bins.
No. S1813.
S1813. That's big.
S1813. Hey, Wei Liang, what about S1813?
Oh, I have heard of that before. One of our customers is using that. Okay, let me just do a Google search. Optimized for G line. So I think if it works for G line, it works for H line.
Okay.
Yeah, I think it should work. Yeah.
So it should work. right, so there-
Broadband exposure. So I think it should work for GH and I.
Okay. So Wei Lang, they're spin coding a sample now. Is that all right?
Yeah, sure.
Cool. All right. Be cool to test it out and see. So who's going to be using the tool the most? Probably who?
Probably the one that sent something.
Okay.
Yeah, they'll probably have us.
I imagine it would be all good film, so it'll probably be his class next semester. Yeah, it's all true.
Oh, Wei Lang, I'm lost in the windows here.
Oh yeah. Too many windows opened. Can you find the Beam Explorer?
Hold on.
So yeah, he was saying that it that should work. Wei Lang, what'd you say it was G-line?
Beeline, I think it's 450.
So like yours is sensitive to G-line 450, and so ours being 405 should be still sensitive to it. So worth trying out and seeing. Oh, thanks, Wei Lang. I think I learned more when stuff goes wrong than when it goes right. All the other installs have been too easy. And all the other installs, we finish in an hour and I leave. I learned nothing about the tool.
Not here.
And here it's.
Everything goes wrong.
The amount of tech calls we have to schedule is a lot.
It's crazy.
Sorry about that.
Not the only
I didn't-
equipment we've had to have like a piece replaced either on delivery. And one of them over there, we had to get completely replaced because it came just completely not working.
You guys should see if you could head to UGIM next year. The conference for multi-user fabs.
Oh, yeah.
They have a lot of good conferences. It's probably more for Venu, I guess, but they have a lot of good conferences on like how to manage maintenance and how to manage people. Like those are getting into a different territory though. Like the MIT fab is more like they're making hundreds of millions a year
Yeah.
selling time in their fab. So they need good software. They also switch their software every like 6 months. They're always complaining about having, so they're switching to the latest and best thing. But yeah, they have like interlocks on all of their tools so that nobody can use them unless they're logged in at the time. Wow. Yeah, Seattle does something like what you guys have here. Like literally half the fab is off limits to all the students and staff and everybody. And like they do all their own maintenance, but they just rent time in the clean room. So, but funny part was they weren't there because they were doing like a university tour on a Saturday. And even though I'd already been in that part of the fab, I just tagged along for fun. They opened up the whole fab. There was like literally 200 people walking through looking at all the stuff that was in that part of the fab that people weren't supposed to be looking at. And when I was walking through the section, I looked at my own tool, which was a spin coder for spin coding lead.
Yeah.
So I was like, what does that do? And the guy gives me a full explanation of what it does. All right. That's really not what you guys are supposed to be doing, but okay.
Hey. Sure.
You guys ever do like fab tours for the new students or something where you walk them all through?
That's what those two students were.
All the time.
One was a freshman, the other one was a junior, was interested. And they usually come from, that's where I came from, was Dr. K's class. He just explains, oh, I run the lab, this lab. We come in and we do things. We always get, it's always this time of the semester, it's like 1 to 2 students that are like, I want to come see that. And then we take them through and just see.
I always imagine the particle counts on that day are at an all-time high.
Yeah. We also don't have many people who like actively use the lab, so
Yeah. As of last year, it was pretty much us and Dr. K was it.
And yeah, it's still right now. It's just because for like people who are in here only with us.
All right, Wei-Ling, they're still working on spin coding. So sorry to keep you hanging.
Live
Yeah, no worries.
for that.
Will you be online tomorrow for the Ohio install?
Because it's, we just have to say.
So what time would that be? That's 6 a.m.
That should be the same time. The same time as today. Was it 7 a.m. for you today?
Yeah.
Okay, yeah, should be the same time.
Okay,
6
cool.
o'clock.
Yeah.
Unless I think at first let me make sure I didn't make a mistake. Because I may have set it for oh, that's right, they are in a different time zone. Okay. Let me take a look. Damn, yeah, they're in a different time zone. I'm sorry about that, Wei-Liang. I didn't realize they're on Eastern time. Is that okay? Is 6 a.m. okay?
Yeah. Sure.
Okay. Sorry about that. I'll try to make sure that doesn't happen again when I'm on the East Coast.
Oh, I think now you're familiar with the tool. You can do the most of the training, right? So,
Yeah, at least I can talk for a long time before you hop on.
yeah. It'll be fine.
I'm gonna guess the resistor they're about to use. We won't see it exposed, right? Or what's your? How often do you see exposure versus not?
I think for this resist, it's quite clear. I just looked at the data sheet, so there is a difference in absorbance between exposed and unexposed photoresist.
So you think the
Yeah.
one that we're about to use we'll be able to see the difference?
Yeah.
Okay. Cool. Yeah, the only other install I've seen have a sample prepared was the very first one we did, North Carolina at Chapel Hill.
Mm-hmm.
Nobody else has had samples ready to go. I've said in every email, have a sample. I guess these guys are working on it.
Mm-hmm.
So any changes to the system tomorrow, or was it shipped in a pretty similar way as all the other systems?
It's still in the wooden crate. So
Still in the wooden? Yeah. Okay, no problem. Yeah. I mean, the foam and everything on the inside is the same, right? The supporting foam?
Yeah, I think we shipped that out before we found any issues with this one, I think. Or was it like too close? And then we decided not to change the packaging. But I'm looking at a few different Pelican cases also. So I wanted to get the size that you were using.
Get the what I'm using?
The size of the Pelican case.
Yeah, I imagine there's a lot cheaper alternatives. Probably the same case, but made by a different company that doesn't charge $500.
Well, I think that's but it's kind of reasonable, right? A crate to me is about $300. So
Yeah, so I guess having brand name Pelican is worth it.
mhm.
If that's the price difference. But custom foam is always more. It's like I think it's like $200 if we want to have custom foam here in America. So it's like $700 all in if you want to have the crate and custom foam. But Pelican goes crazy. They will do. Is Pelican in Singapore as well?
Distributors.
Yeah, do they do custom like crates and foam in Singapore? Like, do they have a
Yeah.
facility?
Oh, but not Pelican though. I'm not sure if
Oh.
Pelican has that. Yeah.
No, it's okay. Yeah, so like you basically upload a like a CNC cut file, and they cut the foam perfectly to the shape that you need. The issue that I had with the crate that I picked though was getting the damn thing out. I put that strap in there to try to make it a little bit easier for you, but man, getting that crate out of getting the tool out of that crate is dangerous because you have to like lift it straight up and you have to remove all the foam first. And your design is way better in terms of that. I guess that maybe with the moisture barrier bag, you could pull that out.
Yeah.
Like physically pull the moisture barrier bag to get the tool out. But yeah, your crate design is still by far the best. Almost having like I don't want to go a larger case because the shipping cost would be too high, but having a case large enough to fit the foam you already made, like the custom foam that you made, and then maybe having some additional supporting foam, for me that would be ideal. I like the foam that you did. I think it's protected the vast majority of the tools.
Yeah.
And Demerco says that I think we're paying for some kind of insurance on every shipment. But it's like everybody at SPS is allergic to using insurance. Every time I bring it up, they tell me it's not even worth it, even if we've already paid for it. Basically, just pay out of pocket, fix it. But it's like, yeah, if there's signs of damage, we should be doing a claim on that. Because, like, for example, this trip, all the shipping costs that you did and we did, this second visit I have out here. I mean, what is that, like $4,000 or $5,000 between us?
Yeah.
Yeah.
I mean, if the shock indicator goes off like the previous shipment, one of the previous shipments, I think that's a crazy amount of force. Because I've never tripped one of these shock indicators before.
Let me ask Selena. Let me double check that it went off because maybe I'm misremembering.
No, the previous one, I think, not at NIU, I think. What was the last install?
Colorado.
Oh,
Was
but
it? No,
okay.
it was me. It was me. It was Linfield University, I think, in Oregon.
Yeah.
Linfield, and then Brett did. Brett did Colorado School of Mines.
Yeah, but I think the crate was bashed up, right? This crate.
Let me.
At NIU.
I have the picture. Let me take a look. NIU.
Back.
Awesome. All right, Wei Ling, they are back with the sample. No, Wei Ling, it's green. I was wrong. So the no indication of the sensors going off on the NIU.
Yeah, but was the crate in good condition?
Yeah. So I have a couple pictures. I'll forward them to you now. Forward. Yeah, this should be hitting your inbox.
Okay.
Yeah, nothing. To me, nothing out of line. Although it does look like Demerco handed it to DHL for part of the shipment.
I see.
And DHL is not known for being gentle.
So I think even in other countries like Taiwan, our distributors have feedback to us that because the crate does not fit onto a forklift, it was handled roughly as well. So I'm not too surprised right now.
So
Yes, yeah.
that will give me some confidence.
Sure. So Wei Ling, so the end user is going to try to get it to work now.
Wow. Yeah. I need to be careful.
That's why we only rate it for pointing. That's the reason. So you can see we're far away from the sample, so let's head on over there. So you can use the arrow keys.
So, and I don't know if it's the same height, so I want to go down.
So we know it's at least thinner, so we're okay. So let's get on over to the chip. And yeah, feel free to physically look in there and make sure that we're not going too low, but we're okay for now. And now we're on the chip.
Yep.
So now we're going to slowly make our way down until we start seeing the chip.
I think we are out of chip now. Yeah.
Around the edge is nice. So then you're able to kind of define that
Yeah,
focus.
Top right.
So
down.
remember, page down, stage down. So in this case, we need to move the stage up. So page up. Almost there.
So,
So we're looking at like an internal camera defect or something. Yes, it does.
yeah.
There we go. And then anytime you want to have the computer try to focus, you just push F.
F.
For focus. So then it achieved it. And your sample's a lot cleaner than ours.
Better be clean.
Okay, Wei Liang. So we are now looking at we're a chip here that is about.
Oh, so it's not still on the screen? I mean, are we not sharing the screen?
We are, yeah. So but he can't see this.
Oh,
So Wei Liang, we're looking at a chip that's like 20 millimeters wide by 10 millimeters tall. Like a fragment. So you're on the far left-hand side of the chip right now. So why don't we move further in?
further in?
Yeah,
Yeah.
and then Wei Liang, can we load up a sample? So on I believe on the desktop. So first thing we're gonna do is push load file. And let's go find that sample that you put on the desktop.
Which one?
So,
What's this?
and Wei Liang, what folder is it in?
I think it's all copied to the desktop, right? So
Oh,
the Hawcross that we use was it's just Hawcross test.
oh, okay. Where are the chips? Like the chip test file.
The new leaf. Yeah.
Like the one with the three or four layers.
It's a GDS file. This one?
Yeah, okay, there we go.
Yeah, we can try this one.
Oh, okay. It's a single layer. Looks like. This is fine for now. Exposure layer, 0. Right field layer, we are not defining any right field layer this time. Is it?
Yeah, so
You okay?
yep, okay.
Okay. So we are on this corner. 0 this, it's already 0.
There you go. So yeah, so we move the pattern into position.
Okay. So
And Wei Liang, is there a way for him to preview his pattern live on the camera feed?
What do you mean?
Can he preview his pattern like live onto his chip? Like, is there like with the shapes with the drawing? Is there a way to preview what the pattern's going to look like on the camera feed?
Not on the camera feed.
okay, so this is good.
Yeah. So what Wei Liang said earlier, and what we should try now is we want to make sure this whole pattern's going to be on your chip.
Right.
So start right clicking over here, and that should bring us over.
Okay, it's moving.
It's hard to see if we're moving or not.
Let's see.
No, we haven't moved
it has
yet.
not moved. Yeah.
So it is a right click, right, Wei Liang?
Yeah.
So maybe it's just not registering. Let me try. So right click with 2 fingers. Yeah, there we go.
Did it move?
Or
Yeah,
did-
it did move.
It did. Okay. Yeah.
And
So then let's move to the far right just to make sure.
0 again.
No, don't push 0 now because we'll lose well, you could push 0 and then your pattern would just be where we are now,
I
but
know, but
you're right at the top of the chip. So there we go.
I need to so very sensitive.
Yeah. Probably easier with a mouse.
Yeah.
You guys have a desktop mouse lying around or an extra? Yeah, if you guys find one, that'd be helpful.
Okay. And then. Okay, so I have 2 fingers.
Yeah, and so go ahead and hover over this area and then actually look at it while you're right clicking. You could see it.
Yeah, you can see that moving.
Yeah, cool. Well, it looks like we're, from what I can see.
Okay.
And are we still in focus?
That's a good
You're-
point.
you're-
I think we're still. We have
So-
changed it.
Your sample's too clean. I can't tell. So Wei Liang, you mentioned that the space bar. No, it looks like our camera's paused.
Oh, yeah.
Thank you.
You can click on the live button again.
Oh, okay. We accidentally clicked the live button. Let's click off the feed. So we're staring at a pause screen.
Yeah.
Let me see where. Hopefully, there's some on the back. Oh yeah.
So we need the mask and then the other have the pocket, you can get another pocket. Pocket. Oh, yeah, we should have process tracking in it. Just kind of, it should be able to.
So it's a lot more.
Oh, it's so much
It
more.
does it out. Yeah, it's a lot more responsive with the mouse.
much more easy.
I can bring in. Here we go. Oh, sorry, we need to turn back on the live. Yeah. Okay, and let's try to make sure we'll put that. That is more like. Okay. Oh, yeah. Cool.
Okay,
So I think we're ready to expose. Run the whole pattern.
but this is a different photo resist, right? So should we do the test first or?
Yeah, Wei Ling, should we run through that test?
Sure. Sure.
Sure.
You can just do it somewhere on the sides.
So what's that?
So let's go to the side to make sure that we're in perfect focus.
Side?
Yeah, so we'll move on over to the chip side.
Okay.
Just
Just want to make,
yeah.
want to make sure we have nice focus.
Yep.
Okay. And then now let's go ahead and load up the calibration.
Okay, and unlock calibration, isn't it?
Wei Ling, what's the next step?
Yep. Unlock calibration.
0805.
PhDs. You got to get memory.
Okay, that's good.
Oh,
And then
wait,
And then wait.
okay. So it's
Calculate.
draw squares. Draw square. Right in the middle. Yeah.
Okay. Oh, okay.
Oh, we still see a little bit.
So
Yeah.
I can see the thing there. Patterns, that's good. That's a
So
good.
Wei Ling, so walk us through. Which one would you pick?
So it seems like the exposure can be increased further. So I would go to settings.
Okay.
If you can just click on settings now.
Yep, got it.
Okay.
Okay.
Did the window pop up?
Nope.
Oh,
maybe
okay. It
it's
was just
in
behind.
the back. The back. Okay.
I think we can bump that up to 800.
So
Let's
from
do it.
here,
So let's change 500 to 800.
so 800 is, but here it's only for the.
But he's saying we need even higher power.
I know, but how did we choose the number 800? Where did we get that from?
Yeah.
All right.
Is it like
Oh,
is it a gut feeling, Wei Liang, or experience, or how do you know to switch
Well,
to 800?
If
Looks
you
like
look from
some
left to
thumbnail.
right, it's getting more and more yellowish, right?
So yeah, yellow's the goal.
Yellow?
Yeah.
So where is yellow?
You see how we've switched? We have a little bit of yellow on some of the edges here. That's the goal. So he's saying it's not enough. So let's bump up the laser power to 800 and let's try the test again.
Oh, okay. Okay.
And then just close Wei Liang.
Unlock or
Yeah, you can just click away.
All right, so just click close.
oh, okay.
Okay, and then let's close this out
Mm-hmm.
and let's draw square again.
Maybe on a different side.
Yeah.
Like if you just
Okay,
move.
so move a little bit. Yeah. I think we might need to click the camera window. So maybe let's move this window over here. And then we'll click the camera window to make it live. And then we should be able to control with this.
Okay. And draw square, yeah. So that's 800.
Oh yeah,
Right.
a lot more yellow.
Much better.
Looks better, yeah. Before we only had yellow here, and now we have yellow from this range.
Writing sorry, this pattern or
Yeah.
this pattern?
No, this pattern. We are trying to calibrate power.
Yeah, it's hard. It's
Okay, this is for calibration.
so
Yeah.
this. Just ignore this for now. So you see right there.
Mm-hmm.
So you can barely make out the pattern, but that's what the camera's referencing.
Right.
So Wei Liang, so give us or your analysis of this.
What are these numbers here? 50
Yeah.
to 400.
Yeah. So one range is I think the exposure power, and then
Uh-huh.
Wei Liang. So Wei Liang, you want to walk me through the axes? Exposure
Yeah,
power
okay.
and exposure time.
Yeah, sure.
We have to make pattern within these squares,
No. This is just to figure out the right power.
right? Power. Okay.
Yeah, what we're doing is we're writing each square with a different writing time and a different writing power. And what we're doing is we're trying to see what is the optimal writing time and writing power for our photoresist.
So, but
So we have a much. So you have a much.
We can figure.
How thick? What's the RPM that we did on this?
what's that?
What RPM did we do on this?
Can you
Our RPM on the spin code.
3000. So we are
3000.
talking about 1.6 microns.
Okay, 1.6.
Around
Okay,
1.6.
so this should be thicker than what we were dealing with by almost a factor of 2. So what we're doing now, because we have a thicker photoresist, is we're having to increase the power, and then we're also exploring increasing the writing time to see what this gets us. So Wei Liang, so looking at this new chart, are you happy with any of these values?
Yeah, I think this has a lot higher chance of success, right? So as long as you are looking at the colors saturating, right? So from left to right. So any of the rows from left to right, if you see the colors
Thank you.
saturating, then that means your exposed power is enough.
Oh, okay. So I just need to.
So you think 800 is enough right here, just because we have one of these that is yellow. Okay.
But what about the writing time? So right now we just in the settings. Let's see what we do. Settings.
The speed is always the fastest, right? The speed is always the fastest.
What's that?
The speed is always the fastest, so we control the exposure only through the laser power.
Oh, okay.
Okay.
Okay, so now we can move around again. And
So keep in mind that when we push home now, we will be defining a new bottom left.
home.
Oh, sorry, 0. Yeah, 0. Yeah.
But if I want to go back to the previously defined reference, can I put home?
Hmm.
Take me there.
Yeah. So no, that should start a homing procedure that would wind us up back in the middle of the stage. Wei Liang, that's a good question. How do we get back to where we previously set 0? Do we just type in 0, 0?
Yeah, exactly.
7
So
0.
you just if you type 0, if you just go to the box and press enter.
Yeah. So if we say that we want to go to 0 by going to 0 and just pushing enter on that, we'll go back to where it thinks 0 is. So you can see on the right hand side, it's where it actually is. So we were at like 500. So if we move over again, you can see this is where it actually is, and this is where we want it to go. So if we just wanted to go back to 0, we just tell it to go back to 0, and this is where we previously defined 0.
Okay. Now it's going to take 800 as the power setting.
It will, yeah. So all right, so we're ready to go. Let me just go back. Okay.
Okay.
Okay. So you should be ready to close. Yep.
And it's going to write it to 500 power.
Yep. So 86 right field. So it'll take a little while.
Oh, there you go. Yeah.
So when it calibrate itself every time, right? Or we have to just follow
Why?
the.
Oh,
So once it's calibrated and nobody has moved the tool or bumped it or done anything to it, it should maintain its calibration. If somebody picks up the tool and physically moves it somewhere else, it's always a good idea to check the calibration again. But it's fairly robust. The other thing is
the right fields are not proper here, so I may have to adjust the right field.
Yeah.
On this one because the stitching is.
Yeah, the stitching is right across the devices.
Yeah. So now that's a good idea to
then have
another
a
page.
separate layer and
Yeah.
have that be its own right field.
Yeah. So you need to have another separate layer here.
Oh, so remember we can have a separate layer. Yeah, so a separate layer that defines what the right field is.
Oh, okay.
So you don't even have to modify your design to like make it smaller so that you can
Mhm.
focus on that area. You can still have a large area and just have the additional layer where you want to focus on, and that will define where your right
Mhm.
fields are.
Pretty cool.
What the maximum thickness of photoresist it can take?
Yeah, so it's all like so what Wei Ling was saying earlier was there is no maximum thickness. What we're dealing with here is a cone shaped beam. So when you're dealing with a situation where you're trying to expose a film that's too thick, you're then having to make some choices here. So this beam the laser's been formed into a beam, to a cone shape. So when you have let's just go crazy and you get a 1 millimeter thick film, right? Way too thick, but let's just say you had that. You would have to pick your exposure area. So would you focus on the top? Would you focus on the middle? Would you focus on the bottom? Wherever you focus, that cone shape is going to be an inverted cone on the other side, and you're going to have not straight walls. So the reason that we use thin films most of the time is because the goal here is to have straight walls.
But to get the best pattern, what the ideal thickness range should be?
So Wei Liang, you never really go on any of your stuff above 1 micron, right?
1 micron.
When you're doing
That-
calibration work.
Thickness of the photoresist, right?
Yeah.
1
Yeah,
micron.
no, I mean that happens as well. 1 micron is normal. I think a lot of people use that. Yeah, I mean the thinner the better, right? 200 nanometers. And
200?
yeah.
Get down to 200. Yeah.
200?
You could use 200. Yeah.
But,
200 nanometer.
Yeah.
200
Yeah. 200.
You can dilute the.
dilute or increase the spin time, spin
speed.
time and dilution. Yeah, dilution also. Yeah. Because it's the photo is very viscous then. Yeah.
But you said we could also do SU8, right? That's pretty thick.
Yeah. So
Okay.
and what we can get into in the future and start showing you is you can also define your focal point. So there's settings on here to control everything that you can imagine. So if you have any problems or if you're having an issue, always reach out to us. If you have at least, we're not going to stop talking to you after a year, but you have a year of application support. That's us helping you out with this. So you're talking about film thickness. You're talking about what I said before on where you focus in the film.
Mhm.
All these are parameters that can be adjusted.
Okay.
So you can define how thick your film is. You can define where we want to focus on the film.
Mhm.
You can define the thickness of the default thickness of a substrate, so that's a little bit easier to get in there and start focusing on it. And one thing we haven't even talked about was that home button. Essentially, that you can do that whenever you want to, but what it does is there's buttons on the end of every axis, and it just moves into the button and then goes to the next one. It just resets everything back to the center position.
So how so this is what 0 to 4,000, so 4 millimeters pattern?
Okay, so we're dealing with 4,000 micron,
So 4 millimeters.
4 millimeters. Yeah.
Looks like it's done, huh?
So you might even be able to see with your eye.
Yeah.
Maybe.
Yeah. Okay. It's good.
Okay.
Oh, you can turn on the high contrast or what? Yeah, looks
So where is the high contrast again?
So remember, we hold down control.
Uh-huh.
and then you push the I think the live button. So
Contrast?
yeah, so hold down control and then push live, and it takes you into that contrast mode.
Oh, okay.
There you go.
So this is where it's stitched.
Yep.
Right?
Yeah, you can see that. Yeah.
Okay. Now I can move around, right?
Yeah, so check it out.
If I do 0,
So you just set the new 0, which is okay. But let's go ahead and
move it.
yeah. So Wei Liang, the software's smart enough to know that since we've already written that pattern, it's not going to move the file right after you 0 again.
Sorry.
So he just pushed 0 after writing. So
Uh-huh.
what does that do in this context? Is that keeps the looks like the file knew not to move, right?
Yeah. I mean, you're changing your 0 point, right? You're changing your reference point. So yeah, the system
But I'm
doesn't
saying
know.
that the file on the left knows that it's already been written, and that's not like it's not loaded to be written again, right?
Oh, you can just write it again right now. If you just define a new 0 point and you write it again, you can do that.
Okay. Yes, that's changing the focus.
Yep.
So we can look at the walls there.
So I want to come out of that contrast mode, then I just do that. Okay. Okay.
I think the narrows.
Yeah, let's do it. So remember, the best way to get the wafer out is to just start backing up. So actually the other way. And then remember, faster is going to be shift hold. And that'll make you go faster. And then Wei Liang, space makes you go slower, right?
Yep.
Yeah, so space would then slow the motions down. So yeah, we can just keep pushing up.
Yep. So that's 4 millimeters. Yeah, should be. Okay. 4 millimeters is still a pretty small pattern.
Maybe one of the kids can see it. My eyes are too old at this point. Yeah, Wei Liang, we're just examining the chip now. I can't see anything with my eyes, but yeah, obviously it's on there.
Yeah. Or you could just develop the chip.
Yeah. Do you have a developer?
We should. Yes. Let me see if I can find the developer. I'm a
Yeah.
341. Sorry, a second.
So
Yeah. So okay. So Wei Liang, do you have to hop off?
yeah, soon I have to start making my way to my office.
Yeah, no problem. I know you have a busy schedule.
Yeah.
Okay.
Mhm.
All right. So what I'm going to do is I'm going to share your contact info and my contact info with the customers, and if they have any questions, they can reach out to us. Is WhatsApp still a good way to reach you?
Yeah, sure.
Okay. All right. Great. All right. So I'm going to spend
Okay.
some time with them here developing this, and I'll let you know how it goes.
Okay.
Yeah.
Yep,
Thank you
thanks.
for taking the call.
Right. Yep. See you tomorrow. Bye.
See you tomorrow. Yeah. Bye.